We want to prove that opposite sides of a parallelogram are congruent by completing the two-column proof below. The nice thing is that we've got a couple things filled in for us already to help. We also have a possible statement box and a possible reason box. And we've already been filled in with the given information, but one thing that we haven't been filled in is what we're trying to prove, so let's get that in right away. We always want to get in what we know, what we can use. So even if we can't fill out the entire proof, at least we can fill out parts of it. So as we take a look at this one, we haven't done any proofs like this, but it's good to at least be exposed to different ones. And again, our given information is that the quadrilateral RSTU is a parallelogram. And consequently, what we know based on the definition of a parallelogram, and I give that away, is that RS is parallel to TU, and ST is parallel to UR. So we did a short unit on parallelograms, but that's the whole idea here. It is the definition of a parallelogram. Got to spell it right. Which is down here in our possible reasons at the very bottom. Another statement that we're given is we're given that angle SRT is congruent to angle UTR, as well as angle URT is congruent to angle STR. And that goes back to our idea here. If you look down here at the bottom, it goes back to the idea. Looking down here at the possible reasons, I'm going to let you decide which one it's going to be here for a minute. But if we go back to the picture, we've got two parallel lines cut by a transversal. So two parallel lines cut by a transversal, alternate interior angles are congruent. And we've got actually a set here, and we also have a set here. So we're going to say alternate interior angles are congruent. Some other information that we can get from our picture here is that this segment, the transversal RT, is a part of the top triangle, but it's also a part of the bottom triangle. So I'm going to mark that up and say that RT is congruent to RT, and once again, that is reflexive property. And remember, reflexive sounds like reflection. So what we know in our triangle right now, or what we know from both of them, is that we've got an angle, an included side, and an angle in that top triangle. We have an angle, an included side, and another angle in the bottom triangle, which means that we can say that triangle SRT is congruent to triangle UTR because of angle, wait, did I say it right? Yep, angle, side, angle. And consequently, if these two triangles are congruent, then we can say the parts of the triangles are congruent. And that is our CPCTC which means corresponding parts of congruent triangles are congruent, which is down here.